Hey everyone, and welcome to the course. My name is Daniel Buckley and I'll be your instructor. In this course, we are going to be looking at learning the Unreal Engine. So, what is the Unreal Engine? Well, pretty much it is a video game engine developed by Epic Games, and it is used all over the industry for many of the great AAA games. Okay, there's probably tons of games that you have played before that have used the Unreal Engine, as it's been around for quite some time now, and over the years they've only gone and added much more stuff and refined all of its different systems. And not only is Unreal graphically great with the games that you can create, it's also very intuitive to use, as the editor is pretty streamlined and there is a lot of different functionality built into the engine so that both new and experienced developers can have a pretty smooth experience in developing their games. So what engine features are we going to be learning throughout this course? Well, first of all, we are going to be installing the engine and having a look at the editor, okay? Understanding what each of the different panels do and how we can use them in order to create our games. Next, we are going to be looking at actors, and actors are basically the foundation of every object in your game, okay? The player is an actor, the player's weapon is an actor, the enemies are actors, the rocks that you hide behind, those are actors as well. We'll be looking at what an actor is, we'll be looking at how you can move them around, rotate them, scale them, so that you can then have the ability to construct your levels. We'll also be looking at lighting in Unreal. Okay, lighting is something that Unreal does very well, and pretty much with minimal effort, you pretty much just need to drag in and drop a light and it can look amazing. Okay, so we'll be looking at the different types of lights Unreal can provide, as well as how we can change them to fit our needs. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out, or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Now let's get started with the first lesson. Hey everyone, in this lesson we are going to be going over how to install and set up Unreal Engine 5. So first of all, I'm here on the Epic Games Store because Unreal is a product of Epic, so we just want to go to store.epicgames.com. And then at the top right corner of the screen, there is a blue download button that we want to click, and that is going to install the installer, and just go along that process of choosing where you want to install it on your computer. And then once that is complete, and once you have signed in, you can create an Epic Games account as well while you're waiting for that download by clicking on the sign in button right here. Once that's complete and you have opened up the Epic Games launcher, then you should be on a screen like this. But if you're not, you can go down to the Unreal Engine tab here on the left. So you have Store, Library, Unreal Engine. We want to click on Unreal Engine. And here we are. So then what we want to do is at the top, you'll see we have News, Samples, Marketplace, Library, and Twinmotion, okay? News is just, updates about Unreal Engine 5 and what things are coming. Samples is where you can download sample projects, and Marketplace is where you can download assets like 3D models, sound effects, textures, those sort of things. But we want to go over to the Library tab, and inside of the Library tab here is where we can install versions of the engine as well as create projects. So what you want to do is you want to click on the install button. There should be an orange install button right here to install version 5.0. I've already got it installed, so that's why it looks a bit different for me. But yes, there should be an install button here to click, and you should then be able to choose where you want to install the engine to. I do believe the engine is around 30 gigabytes in size, so do be warned that it is quite a large download, so it may take some time. Okay, but once you have that completed, then we have the engine installed. You should see there is a launch button right here, or at the top right corner of our screen is a orange launch button right here. So we can click on either one of those to launch up the engine. So we're going to click on that, and in the next lesson, we are going to go over looking at how we can create ourselves a project and what settings we should choose beforehand. Welcome back, everyone. In this lesson, we are going to be looking at how we can actually set up and create a brand new project in Unreal Engine 5. So here I am inside of the library in the Epic Games launcher, and what I'm going to do is I'm going to click on the yellow launch button here at the top right corner, or you can click it on the specific version down here in the list. So we're going to click on that, and it is then going to open up the editor. Okay, so once you click on the launch button, you should then have open the Unreal Project Browser. And this is basically where we can go ahead and either choose a recent project to open, but we have none of those created just yet, or we can go down here and choose a template. Now, Unreal isn't just designed for making games, there's also film and video, architecture, as well as manufacturing and product design, but we're of course looking at making games, so let's click on the Games tab right here. And the first thing we need to choose is a template, okay? You can see there's a number of them here. We've got blank, first-person shooter, third-person, top-down vehicle, and some virtual reality and augmented reality stuff. Now, generally what we want to do is just start with a blank template because we are actually learning the editor, so we don't really want to get a lot of clutter in the way. So we're just going to select the blank template right here. And then on the right hand side here is where we can choose our project defaults. So first of all, do we want to use Blueprint or C++? This is basically going to just be the default layout for whether or not we want to use the visual scripting or the actual writing down code. Now, for this course, we are only going to be looking at Unreal's Blueprint system because it is quite powerful and it is fairly easy to learn, so we'll keep that selected on Blueprint. Target platform, desktop, quality preset we'll set to maximum. Starting content, this just gives us a bunch of textures, sound effects, and some other stuff that we can play around with in the editor, so we'll keep that as well. And ray tracing, we'll keep that disabled as it is by default. Now, with the starter content, do be warned that this will make this project file around 600 megabytes in size, so do make sure you have at least 600 megabytes available to use. We can then choose the project location down here at the bottom right corner. You can just click on this little folder icon if you want to change that. And down at the bottom right, we can change a project. We can give it a project name. So I'm just going to call this one Intro to Unreal. Okay, just like that. And then what we can do is we can click on the blue Create button down here, and that is going to then open up the Unreal Engine editor in our new project. And here we are inside of the Unreal editor. Now, in the next lesson, we are going to begin diving in and seeing what each of these different little windows are, what the buttons do, just so we can get a better understanding of how to navigate and use the editor. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can explore and learn the Unreal Engine 5 editor. So in the previous lesson, we created a project, and now here we are, and probably right now you're wondering, what is all this stuff? What are all these different buttons, these different panels, selections, and all that? It's probably quite confusing right now, but let's take it step by step and look at what each of these things do, okay? First of all, the main attraction is this center window right here, and this is our level viewport. This basically gives us a view inside of our level where we can select objects, move them around, modify them, rotate them, scale them. This is basically where we are going to be building our levels. Now, over here on the right-hand side, we have two panels. At the top, we have the outliner, and the outliner basically lists every single object inside of our level right here, okay? It's basically like looking at a spreadsheet view of our level. Okay, so we can have a look at each of the individual objects. For example, we have a light source right here. We have a skylight. If you scroll down, you can see we have our chairs, our floor, statue, table. So we have all the objects and all the different things that make up our level listed here inside of the outliner. Now, down below is the details panel. And the details panel is very important and is something that you'll be using all the time, because what this does is it basically allows us to have an inside look into whatever object we are selecting. So let's go to our level viewport right here. And what I'm going to do is I'm just going to left click on one of the chairs. So I'll left click on the chair, and you can see that it has this sort of orange outline to show that it is selected. You'll see here in the outliner, it is highlighted in blue, the chair that we selected. You can see it's this one right here. And then down here in the details panel, you'll see that all of a sudden it has been populated with a bunch of information, okay? Now, what this is basically doing is it is showing us what makes up this chair as well as a lot of other properties that we can modify, add, remove, etc. So we can then click on the table, for example, and that will show us the table's information. We can click on this little statue in the middle. That will show us the information there. We can click on the ground, and as you can see, it shows us the information there as well. Now, we're not going to go into too much detail on what each of these things do down here, but you can, of course, scroll down and see that there are a lot of settings. Don't worry, you're not going to be having to modify each and every one of them. A lot of them are quite specialty that you only need to be using in certain situations, but the most common ones are probably the location, rotation, and scale properties, which basically allow you to modify the position, rotation, and scale of the objects that we have in our levels. Also here at the top, we have our main toolbar. It's basically this strip that runs below all the settings up here and above our level viewport, okay? First up, we have our save button, which of course just saves the current project. We have a select mode, which we don't really need to get into just yet. We have a button to quickly add objects to our level right here if we want to add in some shapes or if we want to add in a light or stuff like that. Over here then, we have probably one of the most important buttons, and that is the play button, okay? Clicking on this will allow us to play our game in this level. So if I go ahead and click on this, what you'll see is we spawn into our game. There is also some sound, which I'll probably turn down the video because it can be quite loud. But basically, this is our level playing. And if we click on the level right here, our mouse is going to disappear and it's going to basically lock in like we are playing a first-person game, okay? We can use the WASD keys to move around. And yeah, so basically if we were to build and publish this game right now, this is what it would play like. So being able to play the game in the editor when you are making it is very important because you'll constantly be needing to go and check things, you know, see if the player's jump is the correct height, see if this object is colliding properly, see if the physics are working when you want a ball to roll down a ramp. There's a lot of things that of course you do want to test when making your game. So we can fly around, we can hit into these obstacles. So now how do we get out of this? Well, we can just press escape and that is going to end the play like so, okay? So this is really only the basics of the editor, and in reality, this is the only stuff that you need, okay? There are, of course, plenty of other windows. If we click on the window drop down right here, you'll see that there are dozens and dozens of other windows that we can open up, but those are for specialty reasons, okay? If you want to get into animation, then there is an animation window. If you want to get into making materials, there's that. But if you just want to place objects in your scene, this is pretty much all you need, these three windows right here. Now, another important window is one that we can't actually see just yet, but if we go down to the bottom left corner of our screen, you'll see there is a little button here that says Content Drawer, okay? We can click on that, and this opens up this little pop-up window right here, which basically contains the project files, okay? You can see on the left-hand side here, there's a sort of file explorer layout right here, and pretty much this reflects the files that we have saved on our computer. So we can go here, we can create new folders, we can create new files, and these are what are known as assets, okay? And an asset is basically an object that we use in game development, okay? Something such as a 3D model, a sound effect, an object that we want to save and be able to spawn in again, a piece of code, a texture, pretty much anything that we have to use, any file that we need for our game is known as an asset. And you'll see here we have one folder already, okay, and this is our starter content. Now, the starter content is what we enabled when we created our project, and this, if we open it up by double-clicking, contains a bunch of things, okay? You can see we have architecture, audio, blueprints, HDRI, maps, etc. If we go over to the props folder and double-click on that, this is going to open up a folder which contains a bunch of 3D models, okay? So you can see here we have the chair, which is in our scene right here. We have a rock, we have a statue, we have a window frame. So starter content basically just includes a lot of stuff that we can use in our project, okay? So we don't have to go around looking for 3D models. If you just want to throw something together, the starter content has a few things for you to experiment with. Now, there's also a lot of hidden windows that we can access by opening up objects. So if we go to the chair model here, for example, SM_chair, what we can do is double click on that. And what that will do is open up this new window right here, okay? We can drag it around, Or what we could do is we can click on the little tab right here, okay? And you'll see we have the SM_chair tab here. Let's click and drag that into the main window right here, and you'll see it's just like a web browser, okay? We can have multiple windows open at the same time and have them saved on different tabs, okay? So for example, you might have your main scene here where you're making your game. You might then have another tab which is for all your players' blueprint code. You might have another one for where you're actually animating the player, and you might want to tweak those animations as you're going about. So yeah, you can have a bunch of tabs here. You can have separate windows that you can drag over to your second monitor if you have that. So there's a lot of customization in how you can actually work with the editor. And what we can also do is move around these little panels here inside of our window. So we can click and drag on the edges to sort of resize them however we wish, like so. Or we can undock them like so into their own separate windows, okay, and we can resize them. And if we click and drag on the header here, we can then choose where we want to redock it. So we might want to place it over here, for example, but for the project, I'm just going to keep it back up where it was before, okay, like so. So if we go over to the SM_chair window, which we just opened, you'll see that this is basically a window dedicated to just inspecting this chair model, okay? Because this is a 3D model, it's got materials, so you might want to go into certain 3D models and modify a bit of their properties. That's what you can do here, okay? So you have a very fine control over how your objects, how your assets in your game are loaded in, how they work, and Unreal gives you that in-depth flexibility to do so with pretty much any object and asset that you want to import into your game. So to close the window, we can just click on this little X next to the tab right here, and we are then back in our main level viewport right here. So that is a look at the editor of Unreal Engine 5. There's of course many more things that we can mess around with and have a look at. And throughout this course, we will be looking at a number of different windows, and we'll of course be using the outliner, the details panel here, as well as the level viewport for a lot of our work. So in the next lesson, we are going to have a look at how we can start moving around these objects here, scaling them and rotating them, okay? Because we might want to construct our level differently. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be looking at how we can actually navigate around our level viewport right here, okay? Because right now we just have this static image of our level. But for example, let's just say we have a large open world map and we want to fly over to the other side of the world to have a look at something or move an object around. How do we do that? Well, there are a number of different ways we can do this inside of the level viewport. First of all, what we can do is we can hold down our right mouse button when we are hovering over it, like so. You should see our cursor disappear, and we can then just move our mouse around to look, okay? It's just like a first-person shooter or a video game where we can just look around like so. We can let go, and then we can go about our day selecting objects and doing whatever. But looking around is one thing. How do we start moving? Well, while we have our right mouse button held down and looking around, we can use the W, A, S, and D keys to sort of fly in the direction that we are relative to, okay? So we can sort of fly around like this using the W, A, S, D keys. We can use E to move vertically and Q to move down, okay? E to go up, Q to go down, and W, A, S, D to move around like so. Now, that's pretty cool. We can fly around. We can go over to this chair over here. We can get a close-up look at the statue. And if we have stuff far away, we can, of course, fly over there as well. But what if we have an object that we don't exactly know where it is? Okay, let's just say we go into our outliner here and we want to go over to this chair right here. Okay, but let's just say this chair is a far distance away and we don't really know where it is. Well, what we can do is we can press the F key on our keyboard, and that is going to focus in on that object. Okay, so we can be over here a far distance away. We press F when we have an object selected, and it is going to focus in on it, okay? We can do the same thing for, let's just say we have our player start. So this is basically where our player will spawn. We press F and we focus in on it like so. Okay, that's great. But that's for navigating around our scene. How do we change the orientation, for example, if we want to have fine control over where objects are? We might want to have an overhead view, okay? Well, we can, of course, get an overhead view like this. It's a bit janky to get set up, but as you can see, we now have an overhead view, but again, it doesn't seem exact, okay? The camera still has depth, and we don't really have that sort of level planning, architecture sort of orthographic view. So how do we get that? Well, what we can do is we can go over to perspective right here at the top left corner of our level overview. We can click on that, and we can change all of the different, or we can change basically where our camera perspective is. So right now it is set to perspective, which basically means that it is just a camera that can capture depth. So of course, objects that are further away are smaller on our screen. But we can also switch that over to an orthographic view. And an orthographic view is basically one where depth does not exist, okay? Whatever our camera sees, it sees pretty much straight on. So we can change that to top right here. And as you can see, we now have an overhead orthographic view of our level. We can zoom in with the scroll wheel. We can hold right mouse to sort of drag and pan this around. And it's kind of like we're in a 2D view right here, okay? So we can move it around like so. We can see our chair right here, and we can click it. We can do the exact same for the table. We can do the same thing for the other chair. And we don't actually see our level as it is. Instead, we are seeing it in wireframe mode, okay? And we can see that next to where we choose our perspective, we can see sort of the rendering mode of our level viewport right here. And right now it's set to wireframe. And wireframe is basically there to show us all the different vertices and edges of our mesh, okay? You can see the chair mesh has quite a lot because it's quite a complex mesh compared to the ground, for example, which is just basically a shrunken down cube. So it, of course, is much more simpler. But what if we want to be in this view, but we also want to be able to see the materials, the lighting, the textures, and all that? Well, we can go here, click on wireframe, and you'll see there is a bunch of different view modes we can choose from. And what we want to do is we want to choose the first one, which is called lit. And lit basically has the game render as it would normally. So now we can see our chairs in their full glory right here. We can see the ground, the different materials, and everything. So if you do on this overhead sort of 2D view, that's how you do it. And of course, to get back, we can click on the top right here and go back to perspective. Or we can choose a different view. We might want to view it from the front this time. But let's go back to perspective, as this will then allow us to get back into this sort of 3D world again and fly around. Now, of course, you can use the scroll wheel as well to zoom in and out, like so. We can also hold down left mouse, and left mouse will basically allow us to sort of glide along the surface, okay? So holding left mouse and then dragging it forward will drag us forward, back, and rotate around, okay? So this basically just drags us around the flat surface like so. So yeah, that is just a look at how we can actually start moving around our level right here. Because once we start adding in objects, we want to get a different position. We might want to move an object off screen, go over there, modify it a bit. So yeah, you'll be constantly flying around, focusing in on objects with the F key like so, in order to build your games. And I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at how we can move, rotate, and scale our objects inside of Unreal. So the first thing we need to understand is, what is an object in Unreal? Well, basically, if we go over here to our outliner, you'll see that we have a bunch of different objects and folders. Now, these folders here aren't actually objects in our world. They are just for the outliner in order for us to easily organize things, okay? So you can see here we have an audio folder. This is where all of our audio related stuff like this audio emitter right here, an audio component. We have things like sky and fog, as well as static meshes, which are things for like our chairs and our table. Now, these objects down here, these are what are known as actors, and an actor is an object that has a point in 3D space. So if you have something in your level here which has a position, so basically if it exists in your world and you can see where it is, that is an actor, okay? Most objects in your levels are going to be actors. And it's not just things like 3D models, okay? It can also be something like this right here, which is your reflection capture, and this basically captures the scene around it and applies it as reflections, okay? That's not something you'll ever really see. You're never going to see this little icon. That's just for the level viewport right here. Same thing for this little audio. This icon is only existing here when we are not playing the game, okay? And this is still an actor because it has a point in 3D space. So let's say we want our chair right here, our chair actor, and we want it to actually move. So how do we move it? Well, when I click on it, you'll see this thing appearing down here. And what this is the move gizmo, okay? Now, the move gizmo allows us to move this object in 3D space. Now, you'll see there are 3 different colors. We have the green, blue, and red colors, and those each have an arrow pointing in a different direction. Now, when working with 3D space in pretty much any piece of 3D software or even 2D software, you will have different axes. And if we go down here to the details panel, once we have the object selected, you can see underneath the transform dropdown, we have a location property, okay? And this location property has 3 different values. You can see it's got the little red, green, and blue. And this stands for our X, Y, and Z axes, okay? And the X, Y, and Z axes all together make up a 3-dimensional position. So what we can do is we can click and drag on this green arrow, and this is going to move the chair along the Y axis. And you can see over there in the details panel, you can see that the Y value of our chair right here is changing. So it's around 125 here. We can move it to the left here to increase it like so. Same thing for the red axis, which is for our X axis. As you can see, that's been modified as well. And for the blue axis as well. That is our vertical one. You can also go Control Z to undo. Now, something that's also important to note is if we select the chair again and we go over to the location, we can click on it and we can enter in our number. So let's bring it over to 0, 0, 0, okay? Now, this position right here is the 0 point, okay? This is where all axes are equal to 0, okay? If we select the red axis and move it up, you'll see it is moving in the positive numbers, and if we move it to the left, it's going negative, okay? So pretty much 0 is the center of your level essentially. So it's important to note that objects can move relative to the 0 coordinate right here. Okay, so that is the move gizmo, and you will see, if I just move this chair up a bit so it's on the floor, you'll see that there are these little squares next to it as well, okay? And these little squares, if we click and drag on those, will move it along that sort of surface, okay? So you can see here we have the X and Y axes highlighted on the gizmo, so we can move it along the X and Y. We can also click on this square here, and this will move it along this plane. So there's lots of different ways that you can move your object around, and in the middle we have the white circle, which basically moves that relative to whatever direction the camera is facing, okay? But you won't really use it that often. Mainly you'll be using the arrows here. And of course, you can go in here and manually set a position. So we might want 25 on the X, we might want 15 on the Y, and 50 on the Z, okay? And there we go, and it can move it around like so. You can also click and drag on these properties to increase it like so if you wish. If you want to maybe get a fine-tuned number here that you want, rather than clicking and dragging on these gizmos right here. It's entirely up to you. There are many different ways of doing this. And another thing you may notice is that when you're clicking and dragging on the gizmo here, it's sort of snappy, okay? It feels like it's sort of latching itself and glitching around. And that's because by default, it is snapping itself every 10 units, okay? And you can see here in the location, when I move it along the X-axis, you can see it is snapping in units of 10. And that's because we have snap enabled. Now, to disable that, we can go to the top here where we have this little grid icon, which is blue. We can click on that, and now it is freely moving, okay? And we can move it as finely as we wish. We can click it again to enable it, and we can even click on the number next to it in order to change the amount that it snaps. So if we want to snap 5 units, there we go. Now, as well as moving around, we also have the ability to rotate our object. Now, how do we get the rotation gizmo? Well, if we go to the top here, you'll see there are 4 different buttons right here where my mouse cursor is. Okay, we have the select object tool, which basically allows us to select stuff. And then we have the move tool, which allows us to move things around. And then we have the rotate tool, which we can select by pressing on the button right there. Or we can use E as the keyboard shortcut, okay? W is for the move tool, E is for the rotate tool. And just like with the move tool, we have 3 different axes that we can rotate this object around. So we have the blue for the Z, we have the green for the Y, and we have the red for the X, okay? And you can see here that it is also by default snapping to every 10 degrees. And yeah, unlike moving stuff around, it doesn't work in terms of units like it was with moving, rather it works in terms of degrees. So down here inside of the details panel, we can go to the next line, which is rotation, and we can set that. So I'm going to set this to 0, 0, 0 on all axes, so it is nice and centered here. And you can see that when I start moving along the blue, which is the Z axis, you can see it rotates around like so, okay? There we go. So that is the rotate gizmo right there. Finally, we have the ability to scale our objects, okay? So if we click on the scale right here, keyboard shortcut R, this allows us to change the size of the object. And just like before, we can scale it up along the X, Y, and Z axes as well. So if I want to scale it upwards, for example, we might want to have this chair be very tall. We can click and drag on this blue square right here and drag that up like so. It might not look that good when you're doing it with things like chairs, but if you got things like, for example, geometry or nature sort of items like a rock, for example, you might want your rocks to not all be the exact same size. You might want your trees to be slightly different scales so that they don't all look like they're copy and pasted. So that's where scaling come into play. So we can, of course, scale along all the different axes like so, and we can also click and drag on the center white square to scale it uniformly along all axes. Now, when it comes to scaling, the default is not 0, okay? For position, for example, the default position is going to be 0, 0, 0. The default rotation is going to be 0 degrees, 0 degrees, 0 degrees. But the default for scaling is going to be 1, which basically means 1 times the scale, okay? So it's 100% its normal scale. If we set it to 2 here, for example, that means that this object is going to be twice as big. 5 times as big if we enter in 5, for example, here then, and so on and so forth, okay? So that is how we can move, rotate, and scale our objects inside of Unreal Engine 5. And just like with all the other ones as well, we can also disable or enable the snapping. So scaling right now, you can see it is scaling in terms of 0.25. But if we go up here to where we have the scaling snapping, we can disable that. And as you can see, we now have a nice smooth scale that we can change. Same thing for rotation. If we press E to go to our rotation tool, we can disable rotational snapping by clicking on this little button right here, and we can then rotate it nice and smoothly. But of course, snapping is a preference, and if you do wish to have it there to get more uniform and rigid sort of numbers in your details panel here, then you might want that. Or if you're moving something around, so if we go to the move tool, let's just say you're moving around ground items like this one here. So we have 2 ground tiles right here. Let's just say you want to move them around. Snapping might be the best way to do that, just so that you can actually have that fine control over where exactly it is, and you don't have to worry about trying to finally place it next to an object, modify the numbers and all that. Rather, you can just turn on snapping, and it's going to snap right into the exact same position that you need it to. These are basically the vital tool sets that you need to know for Unreal 5. I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be looking at how we can create ourselves a new level, okay? Because inside of Unreal here, basically the way it is set up is that the engine and the way that you build your games is in what's known as a level, okay, or a scene. And this is basically a self-contained environment which contains a certain number of actors, objects, and all of that. So for example, if you have maybe a menu screen, that menu might be on its own level, which has all of the 2D elements that you can click on and interact with. And then when you launch the game, you might want to load into another level, which is level 1, and then you can go over to level 2, etc. Okay? Games typically have multiple levels, so that's sort of how you can think of it. Now, in the level we have right here, what I want to actually do is create ourselves a new level that is blank, okay? We don't want these chairs, we don't want the sound emitter that we have already, okay? We want a nice blank level to work with. So how do we do that? Well, we can go up to File at the top left corner here and go New Level. We'll click on that, and this window here is going to pop up where we can choose the sort of template we want, okay? We can choose Open World, we can choose Basic, and then we can choose an empty level or an empty open world. Now, we don't really need an open world. We're going to go with Basic here just because it gives us a nice little platform to work with. And the empty worlds are if you don't want a skybox or any built-in lighting to be added by default. Okay, so we're going to click on Basic. We'll click Create. And as you can see, this has created ourselves a brand new level. And we have a skybox, we have a light, we have a ground right here that we can, of course, move around using our move tool, but we're going to keep it nice and still for now. And if we look in the outliner here, you'll see underneath the lighting folder, there are a number of different objects here that are building our scene. First of all, the directional light. This is in charge of giving us, well, light, okay? And a directional light basically acts like a sun does, okay? In the sense that the light beams are all coming from one single direction. And if we click on our directional light and go down to the details panel here, you can see underneath light, we can change a lot of the properties, okay? Such as the light temperature, so we can make it a nice warm light, or we can make it a cooler light like so. We can enable or disable if it casts shadows, and we can change stuff like the intensity of the light as well, okay? So there's lots of things we can modify with our lighting. We also then have exponential height fog. This basically makes it so that there is some fog on the ground just so it's not 100% clear. We have a sky atmosphere, we have a sky light, we have our actual sky box mesh, and we have volumetric clouds, okay? So with Unreal, you can get very deep in how you want to set up your scenes and the lighting and the skies, okay? So there are plenty of different things you can mess around with here. We can have an entire course going over setting up an atmosphere, okay? But we're just gonna close up this little lighting folder here because we don't really need to modify any of those actors in there. What we're going to be doing now is setting up our level to have a player, which is what we are going to work on in the next lesson. But before that, let's go ahead and save this level. So what we can do is we can go to the top left here where with this little save icon, and we can click that, or we can just go Control S, and this is going to open up the save window. Now, what we want to do is we want to save this to a new folder. Now, we've already got our starter content right here, but we don't want to save it here, okay? Because the starter content is sort of the stuff that Unreal is just giving to us, and we want to have our own folder for our own stuff. So I'm going to click on the content folder right here, and I'm going to right click, and I'm going to go New Folder. And I'm going to call this one Levels. Now we can double click to open this Levels folder up, and inside of here is where we can save the file. So I'm going to rename it down here to just be Level 1 and click on Save. So now that is saved into our content drawer. If we go over there and click on the content drawer button here, go over to the content folder, you'll see we have levels, and then we have our level 1 asset right here, okay, which is cool. So the level 1 is now saved to our actual project. So it's in the project files now saved. We can quit out, reload it back up, and it will still be here. And I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at how we can create actors inside of our Unreal levels. Now, first of all, what is an actor? Well, an actor is basically an object inside of our game world that can have a position in 3D space. Okay, so if we look over here in our outliner, we'll see that we have a bunch of objects right here. Now, you can see over here that it has the object type, and it says displays the name of each actor's type. So there's a bunch of different types, such as directional light, skylight, sky atmosphere, volumetric cloud. But at the base of all of this, these are all actors, okay? They all exist inside of our level and all have a sort of existence, a presence. So this floor right here, for example, if we select it, this is an actor, okay? And we can see over here in the outliner, it is of type static mesh actor. Now an actor, as you can see, has a location, so we can move it around. It has a rotation that we can rotate, and it has a scale that we can increase and decrease in size. Now, how do we go about actually creating actors? Well, what we can do is we can go up to the top of our window right here where we have this little cube and a plus, and it says quickly add to the project. So we're going to click on this, and we're going to go down to where it says place actors. And you can see here that there are a bunch of different types of actors. Okay, we have basic ones, which is just creating sort of like an empty actor for us to add stuff to. We can create some empty actors here. We then have lights, so we can create some directional lights, point lights, spotlights, and so on. We then have shapes, so we can create some basic cubes, spheres, cylinders, etc. Some cinematic stuff, some visual effects, some volumetrics, and we can go all classes to basically see all the different types of actors that we can create in our scene, which there are a lot. Now, for this example, I'm just going to go to shapes and I'm going to create ourselves a sphere, okay? And as you can see right now, it has created a new sphere in our level. We can click and drag on these move gizmos to move it up above the floor. We can look and zoom in on it. We can press F to focus in on it as well. And we can also see that it has been added to the outliner right here. Now, as you can see, it is a static mesh actor, just like the floor. And a static mesh is basically a 3D model that doesn't really do anything, okay? It doesn't do anything special, okay? It's just a 3D model that just sits there. Now, with this sphere selected, we can also go down into the details panel and have a look at all the different things that we can modify. And all these things that we can modify here are the component's properties that are based around it being a static mesh actor. And since it's a static mesh actor, we can of course change the actual mesh that gets rendered. We can change the material to basically change the visual look of this mesh. So let's set a material. I'm just going to set it to be clay bricks, like so. We can go down, we can add physics to it, so we can make it so it falls to the ground and rolls around. And then we can also determine collision, okay? So does it collide with objects? What sort of objects does it collide with? Etc. So there are a bunch of different things here that we can modify, okay? We can even determine if it casts shadows or not. Okay, so there are a lot of different properties that we can modify for each type of actor. If I select the skylight, for example, we have an entirely different set of properties here, okay, that have to do with lights and rendering and all of that, okay? So yeah, this is basically just a quick look at what actors are inside of Unreal Engine, okay? They are basically objects that we can add to our world, and there are many, many different types of actors that we can create. We can even create our own custom actors as well. So later on in your games, you might want to create your own custom actors for maybe projectiles, for pickup types, for enemies, and that is because an actor is basically the lowest form of object, and it just branches out from there into all the various different types. So thanks for watching. Hey everyone, in this lesson we are going to be looking at lights inside of Unreal Engine. So here I am in a brand new empty scene, and all we have is a ground and a sky. Okay, you can see over here in the outliner, we have a lighting folder, which contains all of the actors that relate to basically constructing the atmosphere, the sky, and the lighting. Now, in every sort of daytime scene, you'll have a sun, of course, or at nighttime you might have a moon. And that sun or moon wants to emit light in parallel rays, okay, sort of like the sun. So in that case, we would use something known as a directional light. And you can see we have one right here. We can select the directional light. And if we go over to where it is inside of the actual viewport here, you'll see that it doesn't actually matter where this is positioned. We can move it anywhere around the scene and it's not going to change the lighting. All that matters with the directional light is its rotation. And you can see here with this white arrow pointing off in this direction, that shows basically where this light is pointing towards. So if we add in a cube, let's go up to here, and we'll go create a basic, we'll create a shape of a cube here. Let's move it up a bit, move it over. Okay, and you'll see that we have a shadow going off in this direction. That's because our directional light is pointing sort of to the bottom left corner of the screen here, and that is where the shadow is as well. Now, with our directional light, we can select it here, and inside of the details panel, you'll see that there are a bunch of options relating to just modifying the properties of this light. We can, first of all, change the rotation, which basically determines which direction this light is pointing. So if I move it along the y-axis here, what you'll see happen is it's pretty dark. That's because the light is currently pointing up. And the way that the directional light works with the rest of the atmosphere is it actually is a procedural sky. So pretty much the sky will change based on the rotation of our directional light. And you'll see if I keep bringing it over and start bringing it over like this, you'll see that it's sort of like an early morning sunrise here, as the light is almost parallel with the horizon. Oh, let's get a better view here. If I bring the light up a bit more, you'll see it starts to rise in the sky and the sky turns blue. You can also see the shadow of our cube changing as well. And then if I bring the sun down to the horizon here, you'll see that it goes back to a sunset, okay? And the sky changes into a nice orange color. So pretty much for a day-night cycle, all you need to do is, over time, change the Y rotation of the directional light, and then you can have a pretty simple day-night cycle, okay? Alright, so we got the directional light. Now, what else can we do with it? Well, we don't just have to keep the default settings on our directional light here. What we can do is in the details panel, we can scroll down and we can change stuff such as the intensity, okay? Right now it is set to 6.0 lux, so we can increase that. And as you can see, the brightness is increasing as well. Now, you probably don't want to see this bright, so keeping it around the default's probably best. We can also change the light color. So right now it's set to white, but maybe if you're on an alien planet, you might want it to be a greenish color, maybe a red planet, maybe for like a lava planet or something, you might want it to be a reddish color. So you can really change and mess around with all the lighting settings here, okay? Now you can also work with color temperature as well, okay? So over here you can see that there is a use temperature checkbox here, so we can either tick it or not. And down here we can modify the color temperature, so we can get our sun being a lot more warm, or we can make it a lot colder, okay? So if you have a specific color temperature in mind for your scene, you can enter it in there as well. And of course, you can disable or enable the ability for the sun to cast shadows, okay? If you maybe have a very complex scene that you want to be very performance friendly, you might turn off shadows, but you know, it of course looks a lot better with shadows on. So that is a look at a directional light. Now, are there any other types of lights? Well, yes, Unreal actually has quite a few different types of lights that we can use in our levels here. So if we go up to the Add Object to our Project button up here, we can click on that, go down to Lights, and you'll see the different lights that we have at our disposal. Okay, we just looked at a directional light, which we can use as a sun. Then we also have a point light, a spotlight, and a rect light. Now, a skylight is something that's also already built into the scene here, and that just adds a lot more of like the ambient light, and just makes the scene look a lot more realistic. So we're not going to be focusing on that. But a point light, for example, if we select that, it creates an object, an actor in our scene, which has this sort of wireframe sphere around it, and this basically shows us the range of the light, okay, the attenuation radius. And this light, if we see here, it's pretty much like a light bulb. It's pretty much like a candle in the sense that the light rays are emitted from all directions around it, okay, like so. And just like with the directional light, we can go over into the details panel and change things such as the light color. So we might want this to be a red light, so we'll make it sort of like that. We can increase the intensity of that light as well. We can even increase and decrease the attenuation radius, so basically how far this light can go out, or if it's a very small light like a candle, you might want a very small radius on that. Now to get a better look, let's actually select our directional light, and we are actually going to go ahead and disable Effects World, just for now, so that it doesn't actually emit any light, and we are left with our point light right here, and you can see, if we move it up and down, it's basically a point which is emitting light rays from all directions, okay? And it looks pretty cool here. Now, as well as a point light, let's bring the intensity down a bit, we also have what's known as a spotlight. So, just like with the point light, we can create a brand new light, and this time we are going to select Spotlight here. And a spotlight works pretty much like a torch, okay? You have a light source which emits in a cone, like this, okay? Now, we can of course change the properties of that cone. If we select our light here, select our light, we can go over to our details panel, and we can change things such as the outer core angle. So if we want a very narrow light, or if we want a wider light, we can do that. We can also change the inner core angle, which sort of makes it so it's a lot softer or a lot harder of a transition from bright to soft. We can also go down here, increase the attenuation radius so it goes further out. And let's actually position it so it is pointing down on a bit of an angle, like so. Okay, there we go, something like that. So you can see how this is sort of like a spotlight. Maybe if you have a stage or something, you might want to have these lights beaming down, or if you have a street scene where you have street lights, you know, you might want to have a bunch of these street lights dotted around the place. And in that case, if you were creating something like a lamppost, you'd probably want a bit of a warmer light. Now you could go ahead and just change the light color here to something like that, but it doesn't really look that realistic. So when creating lights that are based on real things, I recommend using light temperature, as that much more closely resembles real light in our world. Okay, but of course, if you want to create something like LEDs, or if you want to create some strange, purple magic, then you'd probably want to directly change the light color. But I'm going to select use temperature, and I'm going to bring that down. Okay, and there we go. So now we have our basic little street lamp right here with its light emitting down. We have a point light, which emits light in all directions. Now, finally, we have another light type that we can look at, and that is going to be the rect light. So we can go lights, rect light right here, and pretty much as it sounds, it emits in the shape of a rectangle, okay? So if you have maybe some sort of ceiling that you want to have light emitted through, if you have some sort of surface that you want diffuse light to emit through, rect lights are good. And we can, of course, let's just rotate it down here, move it up a bit as well, move it away. Okay, we can, of course, change the size and the scale of this as well. So down inside of the details panel, we can, of course, change things such as the source width and the source height, and that will then emit in those respective directions. We can also change the barn door angle, so we can make it sort of like more narrow focused, the light, or we can make it so the light has the ability to spread out a bit. These pretty much are able to simulate things like lights on a movie set, where you might have the barn doors to sort of point the light in a certain direction. And yeah, that is just a quick look at the different types of lights inside of Unreal. We can also go ahead, select our directional light, enable effects world again, and as you can see, it gets very bright for a second because the camera sort of is like a person's eye in the sense that it has to adjust. And you can see now that the directional light is active. All these other lights are either not visible at all or very, very dim, and that's just because the way that exposure works. If you have a very bright light source, that is going to overpower pretty much any other light source that there is that is dim. So yeah, that is a look at lighting inside of Unreal. There's, of course, much more that goes into lighting if you do want to explore those avenues, such as light baking and constructing scenes with lights. There's entire jobs in the game industry dedicated to just lighting scenes, so there's definitely a lot to learn in this area. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at physics inside of the Unreal Engine. Now, in many games, there are objects that you can push around, you can knock things over. Physics are a thing that we find in pretty much every game, or not in every game, but in a lot of games. So how can we get physics working here in Unreal? Well, it's pretty straightforward because Unreal has its own built-in physics engine, and really it literally just takes one click of a button to get an object start being affected by physics. So first of all, we need to create ourselves an object. I'm going to go up to this little button here at the top left where we can create ourselves some actors. I'm going to go down to shapes, and I'm going to create a sphere. Okay, here's our sphere right here. Then in the details panel, we can scroll down. I'm going to change the material here from the basic shape material to something a bit better. Let's choose M_door just to make it look something like that. Then what we can do is we can go down to the physics section here, and you'll see that there is a simulate physics property that we can tick. Okay, we're going to enable that, and now if we press play, you'll see that the ball falls to the ground and it is now being affected by physics. Now, the default camera inside of Unreal here, we can fly around, we can collide with the floors, and we can also collide with physics objects, and we can push them. So as you can see, I can sort of nudge this object along to get it moving. Now, of course, since it is a ball, it is of course going to be rolling. Now, we can also combine that with some other stuff. So let's say we want to build a little ramp for this ball to roll down on. Okay, I'm going to go ahead, I'm going to create a cube now. Let's move this cube over here. We can sort of scale it down a bit, change its shape. Okay, something like this. We can then lift this ball up in the air. Now, I'm not going to enable physics on this cube because we don't really want it to fall down. We just want the ball to be able to roll down this hill. And if we go ahead and press play, you'll see that it goes and it rolls down like so. Now, Unreal's physics engine is pretty cool. I mean, you can get quite complex things. You can get entire structures to crumble and fall down, and you can get, basic stuff like this to work. So if you do have a game where you sort of want to roll a ball around and bump into stuff, using physics is something that is very viable and something that you don't need to put a lot of work to get working. Because as you can see here, all I had to do was pretty much enable one button and it works straight away. Now, there are a bunch of other settings here that we can modify. We can enable gravity or disable it. So, for example, if we want no gravity, we can disable that. And so this ball isn't going to fall, but if I give it a nudge, it is still going to move off in that direction as if it is basically floating in space, like so. Now, another thing we can do, if I enable gravity again, we can also change stuff such as the damping. And this is basically drag that is applied to the ball, okay? Linear damping is basically drag that is applied to the movement, and angular damping is drag applied to the rotation. So let's just say we want this ball to basically have a lot of angular drag, which basically means that after a while of rolling, it's going to slow down. Because right now, if we press play, you'll see that as it rolls, it's pretty much going to roll forever, or it's going to take a very long time for it to stop rolling. So for the angular damping, let's set that to be 5, and let's press play. And you'll see that as the ball rolls down, it's rolling down a lot slower, and it stops pretty much just as it gets off the platform. And that's because this ball does not want to be rolling, okay? The angular damping is basically being applied to basically counteract any rotation that the physics system gives it. We can give it a nudge, it's going to roll a tiny bit, but it's pretty much not wanting to roll anywhere, okay? Now, something else is that this ball right now, if we go down to our physics section, you can see here under mass, it weighs 109 kilos, okay, kilograms. And that is because that this ball is having its mass automatically generated once it's created based on its volume and its size. So Unreal is sort of estimating how much it would weigh in the real world. Now, 100 kilos is pretty heavy, so what we can do is we can actually override that by enabling the mass right here and filling in our own value. So let's give it a value of 1, okay, so 1 kilo. Now, if we go ahead and press play, you'll see that this ball, it doesn't really behave any different, but it does weigh only 1 kilo. So yeah, that is a look at Unreal's physics system inside of its engine. Again, there is a lot more stuff that you can mess around with and tweak to get your game working the way that you wish. And when it comes to character controllers as well, they have their own physics such as drag, such as in-air control and all that. There's plenty of stuff to work with when it comes to physics. So thanks for watching. Congratulations on completing the course. We just finished looking at how to create games inside of the Unreal Engine. So let's quickly go over the different features that we explored. Okay, first up, we looked at how we can basically navigate the editor, and we learned about the different panels. We also looked at the blueprint screen and a general gist of how the engine works with the different windows, and each of those different windows having a collection of different panels that relate to what you're doing within that window, such as the level editor, which had panels dedicated to exploring our scene and placing in objects, moving them around. We could view them all in the outliner. We then looked at working with actors, so we basically learned what an actor is, we learned how to move them around, rotate them, scale them, as well as the different snapping options. We then looked at the lighting inside of Unreal, just a basic overview of how you can add lights, change their color temperature, change their attenuation radius, intensity, so that you can build out your scenes. Zenva is an online learn academy with over 1 million students. We feature a wide range of courses for those who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the course instructor with the included course files. So thank you very much for following along with the course, and I can't wait to see what you start to create in Unreal. Hey everyone, in this lesson we are going to start with our first micro project. So what I've got here is the Unreal Project Browser. Pretty much when you launch it from the Epic Games launcher, you should have this window open. Now I'm going to go down to the Games tab here. I'm going to select the blank template. We can give it a project name, we can choose the location where we want to save it to, and then we can click on the blue Create button right here to create our new project and open it up inside of the editor. Okay, and here we are. So we have created our project, the editor is now open, and first things first, we need to go down to our content drawer here, and I'm going to create a new folder which is going to basically store all of the assets for each of the different mini projects we're going to create. So the first one, we can right click, go new folder. I'm going to call this one Popper, okay, and this is going to be our Popper project. Now, what we need to do then is create ourselves a new level because we don't really want to be working with our Popper project in this scene right here with these tables and chairs and everything already set up for us. Okay, so we're going to create a new level. So to do that, we're going to go File, New Level. I'm going to select Basic right here, click Create, and that is going to create ourselves a brand new level right here. Okay, so we can navigate around it just like before. We got our lights, we got our ground, we got our skybox. I'm then going to go Control S, or you can click on this little save button at the top left corner here to save this level. I'm going to go over to our Popper folder, and inside of that, I'm going to save this as Popper level. Okay, hit save, and there we go. So it's saved. And now what we need to do is create the actual thing that we want to pop. And in our case, that might be a balloon, for example. So what I'm going to do is I'm going to open up our content drawer, open up the Popper folder, and I'm going to right click. I'm going to create a new blueprint class, and we are going to make it of type actor. Okay, we don't really need to give any controls. We're not going to be moving it around the keyboard. It's not going to be walking around our scene or anything. So it's just going to be a basic actor. Okay. And I'm going to call this one, we'll call it Balloon, okay, like so. Then what we can do is double click to open it up inside of the blueprint editor right here, okay. It's its own separate window, so we can click and drag on this balloon tab to dock it over in the main tab group, pretty much like a web browser, okay. If you've used a web browser, you should know, the general structure of how tabs and windows work, so we can do it just like that. Now, inside of the balloon blueprint editor right here, what we need to do is, well, create our blueprint. So for this, what we're going to do is we are first of all going to create a 3D model. So we're going to go Add, and I'm going to create a sphere. So we can search for sphere. There we go. We got one right there. We've created our sphere, and that's pretty much all we need to do for components for this blueprint. Okay, we pretty much just need a static mesh component, which is going to represent our balloon. Now, along with this, we might also want to give it a different color because right now it's just this white color, yet balloons, they're red, green, blue, all that. So we can go down to our materials tab right here in the details panel after selecting the mesh, and we can choose a material here, but, it doesn't really have the material we want. So what we can do is we can actually go ahead and create our own material. Now, do be warned that Unreal's material editor is, it can be quite complex. You can create very, very detailed and specific materials with it. Yeah, in our case, we just want to give ourselves a colorful balloon. So what I'm going to do is I'm going to go to our content drawer here. I'm going to right click, and I'm going to create a new material, okay? And I'm going to call this one Balloon Material. Now, a material is basically a texture or a visual look that we can give to a 3D model or an object, okay? It basically determines how the pixels of our sphere are going to be rendered on our screen, okay? So we can make it translucent, we can make it glow, we can make it wobble, pretty much whatever you want to do, you can do with materials. So I'm going to double click to open that up inside of the material editor here, and you may notice that it looks a bit like the blueprint visual scripting. We got nodes, we can right click, we can create new ones, yet all these nodes and the general way that we go about making it is very different, okay? So we're not going to spend too much time here because you could have an entire course going over materials and how to create them. So what we're going to do is we are just going to make it so that we can plug in a color to our material. So what I'm going to do is I'm going to right click and I'm going to search for a vector parameter right here, okay? Vector parameter. And basically what this is basically a node where we can give it a color. And you see here that we have the different outputs, okay? Now, these different outputs, the white one is basically going to output the red, green, and blue values, okay? So all of them together to make up the color. This red output is going to output just the red channel, the green channel, the blue channel, and the alpha channel, okay, so transparency. Now, to make this simple, all we're going to do is click and drag on this first output and plug that into the base color input of our balloon material node right here, okay? So the base color, we are basically setting that, and to change it, we can just double click on this little black box here. We can then modify the color to whatever we wish, so we might want a nice reddish, something like that there. We can click OK, and we should see that our balloon now looks like this. Okay, so we have our balloon material set up, okay, nice and basic. Pretty much we're just giving it a color. We can go ahead, click on the save button right here. That's going to save this material. It may take some time. We are then going to go back to our balloon blueprint right here. And in the balloon blueprint, what we need to do then is click on our sphere, go down to material, drop down here, and we are just going to select or search for our balloon material. And there we go. So our sphere now has this balloon material, which is great, okay? And whatever changes we make to that material in the material editor right here, those will be applied to the model. So we can click compile, we can click save, we can then go back to our popper level here. And what I'm going to do is I'm just going to go into our content browser and I'm going to drag in a balloon, okay? I'm going to drag in a balloon like so. We can then copy it or duplicate it with Control D. We can then move this over here, we can create another one, move it over there, maybe lift it up a tiny bit, and just create a few different balloons here that we might want, okay? Like so. Now, if we go up to the top here and click on the play button, you'll see that we press play and, well, nothing really happens. We can, go into this little camera here, zoom around, have a look at our balls, but nothing's really happening, okay? So one more thing we're going to do is we are going to give them gravity. So let's go to our balloon blueprint right here, select our sphere, go down, and where it says simulate physics, we want to enable that, okay? So now this balloon or this ball is going to be affected by gravity, collisions, it's going to be rolling around, so we can compile that, save it, back to our popper level, press play again, and as you can see, they all fall to the ground, like so. Alright, so in the next lesson, what we are going to be doing is we are actually going to be setting it up so that when we click on these balloons, they will start to increase in size, and then eventually, once they reach a certain threshold, they will pop. So thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be setting it up so that our balloons can increase in size and then eventually pop. So let's go over to our balloon blueprint right here, and we are going to go over to the event graph, okay, where we have our visual scripting. Now, what we're going to do is we aren't going to actually be detecting mouse clicks inside of this blueprint, okay? The individual balloons aren't going to be checking for mouse clicks. Rather, we're going to have a separate blueprint, which is going to be the player controller, which is going to detect mouse clicks. It's then going to determine which balloon we have clicked on, okay, which instance of the blueprint we have clicked on, and then it is going to send a message over to the balloon to tell it that it has been clicked. So how do we do that, and how do we set it up to receive that message? Well, pretty much we are going to create a function that the player controller is going to call on the balloon that it clicks. So what we need to do is create ourselves a new function, okay? So down here inside of the My Blueprint panel, what I'm going to do is I'm going to go over to the Functions tab here, click on a little plus here, and we are going to create a new function. And let's call this one increase size like so, okay? So it is called increase size, and a function is basically a set of nodes that can get triggered whenever we wish, okay? So at any time we can call the increase size function here, and it is going to call whatever structure of nodes we have. Okay, it's kind of similar to an event here. In our main event graph, we have begin play, which gets triggered once at the start of the game. So that you can think kind of as a function, yet not really. A function can be called multiple times whenever we wish. So what we could do is string this increase size function multiple times in a row if we want to. And overall, it just makes it so that you don't have to create a lot of copies of the exact same nodes, okay? So if you ever see that you are having a bunch of nodes that are very similar, you can put it into a function and just call that function multiple times. It saves space and it saves time. So inside of this function, what we want to do is increase the scale of our sphere here, okay? So if we select our sphere, you'll see down here we have a scale property, and if we set that to 2, or 21, you'll see that our sphere increases in size based on that scale number. So what we need to do is when this increase size function is called, we want to increase the scale. And to do that, what I'm going to do is I'm going to click and drag from the control flow here into a set world scale 3D node right here. And make sure that we have our sphere here connected to the target, okay? Because the sphere model is what we want to increase in size. And then down here, you'll see that we have another input, and this input is basically going to be the scale we want to set. Now, we don't want to manually set the scale right here, rather we want to increase it over time. So how do we do that? Well, pretty much what we want to do is we want to get our current scale, and we want to add, for example, 0.1 to it, okay? So every time this function is called, we want to set the new scale to be whatever the current one is plus another number. So to do this, I'm going to right click and I'm going to create the get world scale node for our sphere. So the get world scale node, basically this is just going to get the current scale of our sphere, and we're going to plug that into an add node, okay? So we'll create an add node here, and then we'll plug that into new scale. So now we can add a number down here, okay, along the X, Y, and Z axes. So I'm going to make that 0.1 on the Y, X, and Z values here. So pretty much what we are doing right now is when set world scale 3D is called, it's going to look for the target to set the scale for, which is our sphere. And then it is going to have another input which is going to determine the new scale. And that new scale is going to be our current scale plus 0.1 on all axes. So every time we click on our sphere, it is going to increase its scale by 0.1. Then what we need to do is we need a way of checking to see if the scale has reached a certain value. So I am going to then plug the control flow into a branch node, which can take in a Boolean value, okay, a true or false condition. And if it is true, then this control flow will output. Otherwise, the false control flow will output, okay? So what is the condition that we want to check? Well, the condition is going to basically be if our world scale is greater than a certain value. So we can still use this node here. I'm going to branch that off here, and I'm going to create another node called vector length, okay? Now, vector length is basically the length of this vector. And what that basically means is it gets the X, Y, and Z values, and it basically determines how long it is. So if we have an X, Y, Z of, let's just say we have an X of 5, a Y of 0, and a Z of 0, that is going to be a vector length of 5. If we have a X of 2, a Y of 2, and a Z of 0, and that's going to basically, use Pythagoras to determine the length of that. So it's going to be somewhere around, 2.3, 2.4, or something like that. So basically, vector length is just an easy way to get the length or the magnitude of this vector. We're then going to plug that output into a greater than node, and we want to see if this is greater than a number such as 3, okay? So if our scale vector length is greater than 3, then this is going to be true, otherwise it's going to be false. Then what we can do is go back to our branch node here, and if that condition is true, what we want to do is we want to just destroy the balloon, okay? Later on, if you want to add maybe a particle effect or a sound effect, like a popping sound, you can do that. But for us, we are just going to destroy the actor, like so, okay? So create a destroy actor node like so, and that should be everything set up and ready to go. So pretty much what we are doing here is we are, first of all, whenever the increase size function is called, we are setting our world scale to be our current scale plus 0.1 on all axes. Then what we are doing is we are going into our branch node where we are checking a condition, and that condition is whether or not the length of our world scale, okay, the vector length, is greater than 3. So if it's greater than 3, it's going to be true, thus destroying the actor. Otherwise, if it's not greater than 3, then we're just not going to do anything, okay? We're just going to increase the size and leave it be. So now that's all compiled, in the next lesson we are going to be creating our player controller, which is going to be detecting clicks from our mouse. It's then going to determine which of these balloons we have clicked on, and it is then going to basically go into that balloon and it is going to call the increase size function. So that's what we're going to be working on in the next lesson, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be setting up our player controller, which is going to allow us to actually determine which of these balloons that we are clicking on, thus calling their increase size function. So what we're going to do is we are going to go ahead down to our content drawer here, and inside of our popper folder, I'm going to create a brand new blueprint class. And this is going to be of type player controller, okay? And a player controller is generally used to detect inputs, call certain events or functions depending on those inputs, okay? So for example, if you had like a multiplayer game where you had multiple people with different controllers, the player controller blueprint would be in charge of determining, which control is determining which player. So we're going to create a player controller right here, and I'm going to call this one our popper controller. Then what we can do is we can double click on it to open it up inside of the blueprint editor. We can just ignore the camera right here and instead go over to our event graph. Now inside of the event graph, what we're going to do is we first of all need to make it so that our mouse is visible, because if we go back to our popper level and press play, you'll notice that if we click in our scene, our mouse disappears, okay, and we can't really get it back. So what we need to do is we need to make it so that our mouse is visible at the start of the game. So what we're going to do here is we're going to go over to our begin play node here, which basically executes its control flow once at the start of the game. So we're going to drag that out, and we are going to create a new node called set show mouse cursor and tick that box like so. Okay, so now at the start of the game, our mouse should be visible. Now, we can't really test it just yet because we do need to do a bit more setup, but we are going to check that out very soon. Next, we have the event tick node, which we are actually going to delete since we don't actually need that, and instead we are going to right click and create a new node called left mouse button. Now, left mouse button, basically this is an event node which gets triggered when our left mouse button is pressed or released, okay? Now, we want to do stuff when it gets pressed. So when we press down on our left mouse button, this event here is going to execute. And what we want to do is we want to do something known as a raycast. And a raycast is basically like a laser beam, okay? You can think of it like shooting a laser from a certain position along a certain direction. And whatever that laser hits, it can tell us information about it, such as how far away it was, what we hit, the position of the objects, and other information. Now, in our case, what we want to do is we want to basically shoot a laser from our mouse cursor into whatever direction we are facing, okay? So in our case, if our mouse is over here, then we're going to be shooting a laser off into the direction it is facing. And pretty much what we want to do here is we want to check to see if that laser has hit a balloon. So how do we do this? Well, what we're going to do is we're going to create another node here, and this one is going to be called get hit result under cursor by channel. Okay, it's quite a mouthful, that node name, but that is the node that we need. And basically what this is going to do is it is going to get a hit result. So a hit result is a raycast hit, which is basically, like I said, like a laser beam that we're shooting. We can give it some properties here, such as inputs, but we're actually going to leave all of those as they currently are. And instead, we are going to go to this hit result output, and we're going to drag that out, and we're going to plug this into a hit result node like so, okay? Break hit result. Now, what this basically does is this allows us to have a look at all of the different outputs that it can give us, okay? So when we call this hit result, okay, once we shoot off this laser, it is going to return to us a hit result which contains a bunch of information about the object we hit, such as, the time that we hit it at, the distance, location, the impact point, the normal, the actor that we hit, the component that we hit. So pretty much you can get very specific with your hit results here. Now, what we want is the hit actor, okay? And we want to know whether or not this is a balloon, because right now we could be hovering over the ground and the hit actor would be, the 3D model of the ground. And we don't want to try and call an increase size function on the ground. That's going to, return to us some errors. So instead, what we want to do is drag out from hit actor, and we are going to plug this into a cast to balloon node. Okay, so cast to balloon. What this node here is doing is basically it is going to take an object as an input. It is going to try and convert it to a certain type of blueprint. Okay, so it's going to try and convert it to a balloon. If it is able to convert it to a balloon, this control flow is going to output. Otherwise, the cast failed is going to output, and that can then, log an error, or in our case, not do anything. So I'm going to plug the left mouse button pressed into cast to balloon. Now, if the object that we have clicked on is a balloon, then this control flow is going to be called. And in that case, what we want to do is we want to call the increase size function of our balloon. So I'm just going to type increase size. It's going to create that node here. And then what we want to do is plug the as balloon output into the target of the increase size function. Okay, so it knows what balloon to call that function on. So there we go. That is how we can detect inputs from our mouse. Then what we are doing is we are shooting a laser from our mouse towards wherever we are facing. It is then going to take the actor that we hit. It's going to try and cast it to a balloon. So it's going to try and convert that to a balloon. If it is a balloon and it converts well, then we're going to call its increase size function. Otherwise, we're not going to do anything. Now what we need to do is we need to actually have this controller work. So I'm going to click compile. I'm going to return back to our popper level. And what I'm going to do is I'm going to create one more blueprint, and that is going to be our game mode. So game mode base is going to be the parent class, and I'm going to call this one our popper game mode. Now, the game mode blueprint is in charge of basically determining, the various settings and overall game functions of our level right here. So I'm going to double click to open that up. And inside of the game mode, what we're going to do is go down to the right hand side on the details panel. And you'll see here we have a player controller class. And this is where we can assign our popper controller. Okay, so the popper controller is assigned. We can then click compile. We can then go back to our popper level. And if we go over to the world settings tab right here next to our details panel, if you don't have that, you can go up to window and then down to world settings here to open that up. And pretty much what we want to do is go down to where we have the game mode override. We're going to click on where it says none, and we're going to set that to be our popper game mode. So what we are doing there is we are basically giving this level here the popper game mode, and that popper game mode has set, if we click here, it has set the player controller class to be that popper controller which we just created. So when we press play, this popper controller is going to be active, and it is going to basically be receiving these event calls. So that's quite a lot to set up some mouse inputs, but that's what you need to do with Unreal. So now what we can do is we can make sure that everything is compiled, go back to our popper level, press play. You should see that the mouse cursor is also now visible, which is great, meaning that the popper controller is working, and we should try then click on one of these balls. So I'll click on this balloon here. As you can see, the size is increasing, and after the length of that vector has reached 3, it should then pop, like so. We can go along and do that to all of the other balloons as well, like so. And there you go, that is our basic balloon popper minigame set up and ready to go. Now in the next lesson, we are going to be looking at loops. Hey everyone, in this lesson, we are going to have a bit of a challenge, okay? So we have our balloon popper game here. But what I want you to do is have it set up so it looks like this, okay? When we click on the balloons, they jump up into the air, as well as increasing in size. And then after they pop, they explode like so. Now, this may look very complicated, okay? But it's only a couple nodes really that we have to use, because Unreal's blueprint system does a lot of stuff for us, okay? So on screen right now is the list of nodes that we will be using, okay? So when we click on a balloon and it is not going to pop, we want it to jump into the air. Yet when the balloon is popped, we want it to basically have an explosion effect, okay? And we are going to be using these nodes on screen in order to accomplish that. Okay, so here inside of our balloon blueprint, I want you to have a go at trying that challenge, okay? It may be a bit hard, but it will introduce to you a couple new mechanics of Unreal. So I'll be right back to see how you're done. Okay, so I hope you had to go at that challenge. Pretty much what we want to do is we first of all want to have that explosion effect. So what I'm going to do is I am going to remove this connection between destroy actor and the branch node by just right clicking on our branch node and going down to where it says break node links. We'll just reconnect these ones here real quick. And then in between this, we want to create a node called spawn emitter at location, okay? And an emitter is basically a particle effect or an effect that we can spawn in. Now, if you did start your project with the standard assets that came included with Unreal, then you should have a couple particle effects already built in. So from true, I am going to bring this into the spawn emitter at location and then plug it into destroy actor, okay? We can't destroy the actor first, then emit at location because it's going to have issues with trying to find the correct location, all right? So over here in emitter template, we can click on where it says select asset, and I'm going to choose the P_explosion, okay? So that's the explosion particle effect. Now we need to give it a location to spawn at, and we want it to spawn at, well, our balloon's location. So I'm going to right click and I'm going to create the get world location in brackets sphere. Okay, that's going to create this node here with a little sphere input. We're going to plug that into location like so, and that is the explosion effect set up. Okay, spawn emitter at location, that's pretty much all we need in order to create a particle effect, and then you can modify things like the rotation, scale, does it auto destroy, and is it auto activated, stuff like that. So we can compile, go to our level, press play, and now you'll see that when they pop, they have that explosion effect. Now, how do we set it up so that the balloons sort of bounce up in the air? Well, that is by interacting with the physics system, okay? Now, if we select our sphere here and go to the details panel, you'll notice that under the physics tab here, we have simulate physics enabled. That is why our spheres fall to the ground at the start of the game, because they're being affected by gravity. Now, as well as this, there are a bunch of nodes that we can use in order to interact with the physics system. One of those nodes is the add force node, okay? So add force in brackets sphere. We want to create that here, okay? And then from the false output of the branch, so if we are not ready to pop, we'll plug that into add force like so. And then what we can do is we can give it a force vector. So basically the direction and amount of force that we want to apply. Now we want to basically shoot our sphere up in the air. So we're going to go over to the Z value, which is verticality. And I'm going to set this to something such as 15,000, okay? And then also make sure to enable accel change, because accelerate change basically means that we are changing the acceleration so that the effect is much more punchy rather than a slow gradual increase of speed. We are basically whacking it like a golf ball. All right. So we can compile that, go back to our level, press play. And now when I click on this balloon here, you'll see it bounces up in the air a bit and then pops like so. So yeah, that's just how you can add some extra game feel and sort of responsiveness to your game elements, okay? Particle effects, we have the size increase, we also have the popping. As well as this, you can also maybe add in some sound effects to make it, you know, a pretty immersive experience. So yeah, that is a look at how we can spawn particle effects like so, and also adding force to our physics objects. So thanks for watching. Welcome back everyone. In this lesson, we are going to be working on setting up our environment. Now, right now, you can see we have a pretty bland environment right here with just the rings, the floor, and the default sky. So what we're going to do is we are going to go ahead and use Quixel Bridge in order to get some high quality photo scan assets into our game here. So to do this, we're going to go up to Window. We're going to go over to the Quixel Bridge. Now, Quixel is basically a library of hundreds and thousands of different photo scanned 3D models. So these are high quality models that we can just drag and drop into our project for free, okay? So in the bridge here, what we're going to do is I'm just going to undock this window because we do sort of want it in the same view as our level here. And what we're going to do is we are just going to search for what we want. So on the left hand side here, you'll see there's a little planet, and I'm going to hover over that. Well, I'm going to click on it, click on environment, and then environment here, we're going to go down, click on natural, and as you can see, there are plenty of different environments we can choose from. I'm going to go Arctic ice and snow, just because I think that'll be pretty cool for a playing game. And yeah, we can then go through, click on an asset that we might like, and you may have a option down here to log in before you actually download these. And make sure you do that. Just log in with your Google account, with your Epic Games account. There's plenty of ways to log in. So once you do that, what we can do is we're not going to click on download because that will download it to our computer and makes it a bit hard to find. Instead, what we're going to do is we're going to click and drag on the thing that we want, and we're going to click and drag it into our level here. And then you'll see that it spawns in like so, okay? We can then scale it up, move it around, rotate it, and this basically just acts as a 3D model. And depending on which quality you set here, depends on, of course, the size of the textures and the size of the model. But overall, these models do look pretty good. And something else we can do is then on our ground, we can click and drag on this material to apply it like so. And there we go. We have that snow texture now applied to our ground. What I want you to do now is just go through and drag in the 3D models that you wish to create and set up your environment. Okay, there are plenty of different models and environment set pieces here. So set those up and also go ahead and start duplicating these rings and positioning them in places where, you might have a nice challenging flight game to play. So I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Pretty much just start placing those models around. As you can see, I also put these rings around so the player has to fly through them. And I also got some other ground assets here to just add to the environment. So we can press play and test it out, okay? Increase our flight speed, make it over to the ring little course I made over here. And there we go. So as you can see, you can pretty much create whatever sort of flight arcade game you want. You might even want to start adding in some weapons to the planes if you want. You might add some targets that you could shoot down. Really, there's a lot of things you can do with this little plane blueprint right here. You can, of course, create rings like we've done. You can create weapons, create targets. You might even want to create a race around an obstacle course with collisions on the wall so that if you were to bounce into them, the plane would explode. And yeah, that is our plane game inside of Unreal Engine. Thank you for watching. Welcome back everyone. In this lesson, we are going to be setting up our interactable blueprint. Now, in this game, we are going to have interactables dotted around our environment. So you might have a door that you can open up. You might also have a fire pit that you can turn on and off. And you might even have something that you can look at, interact with, and it displays some text on screen, okay? This interactable system is going to be very expansive, and it's going to allow you to create pretty much whatever sort of interactable thing that you want. Now, the first thing we need to do is create a base interactable blueprint class. And this is basically going to be the basis for all other interactions, okay? So what we're going to do is go to our content drawer, and we are going to create a new blueprint class of type actor, and this is going to be called interactable, okay, like so. We can then open this up inside of the blueprint editor, and we're not going to do a lot in here, okay? We're going to do a few things, but it's going to seem a bit weird because it doesn't really matter that much what we do right now because none of it is really going to affect the game just yet. But what we want to do is we want to first of all go to our event graph here and delete these 3 nodes that are made by default because we won't be needing those. And instead we are going to create ourselves a custom event. Now we've already worked with events in this course so far, okay, with our interaction events right here. whenever we move forwards, backwards, or something like that, or whenever the game starts, it triggers an event. An event is basically a node that emits power, basically. It basically triggers the nodes in its chain, and that's what we're going to do here. So inside of our interactable, I'm going to go custom event, go down to where it says add custom event, and I'm going to call this one begin interaction. Now, begin interaction is going to be called when we are hovering over this interactable, and when we're hovering over this interactable, we then press E or whatever key to trigger it, and that is then going to initiate the interaction by calling this event right here. Now, what are we going to do from this interaction here? Well, first of all, let's create some variables. And these variables are going to be, the first one, this is going to be can interact, and the second one is going to be single interaction. Now, with can interact, this is basically going to be a true or false for whether or not we can actually interact with this interactable. So for example, there might be a door that we can only open once, and once we open it, we don't want to be able to interact with it again, okay? We only want to be able to interact with it once, and that is going to be basically setting can interact to false after the initial interaction, thus not letting us do it again. And I'm going to click compile because we want to set this can interact default value to be true, okay? So make that true. And then for single interaction, this is going to be something that is instance dependent, okay? And basically what that means is whenever we drag in a new blueprint into our level, we want to decide whether or not this is going to be a single interaction, because something like a door, for example, we only want to interact with once, yet something that displays text on our screen, maybe there's a note on the ground or something like that, we want to be able to read that as many times. We want to be able to interact with that as many times as possible. So what I'm going to do is on single interaction, I'm going to go and set instance editable to be true. And we'll just keep the default at false for now though. Okay, so then on begin interact, we want to plug this into a branch node. And this branch node is going to check to see if single interaction is true. Okay, so if single interaction is true, then what we want to do is set can interact to false. Okay, like so. Now, what we're doing here is basically when we interact with whatever object this is, we are checking to see if single interaction is true. Now, if it is true, then that means we want to run whatever interaction logic there is and then set can interact to false, because we don't want to be able to interact with this object again. Yet if single interaction is false and we can interact with this as many times as we wish, we're not going to be setting it to false, okay? We're just going to not be doing anything. Now, you may be thinking that, okay, we have all this, but this doesn't really do anything. We're just changing the value of two variables. And the reason why is because this interactable blueprint is not going to be what we add to our levels. Rather, we are going to inherit from it. Remember, when we create a new blueprint, we can choose a parent class. Well, for our doors, for our fires, for our notes, this interactable blueprint is going to be that parent class, okay? And from here, we are going to extend this begin interaction event in order to add our own custom logic at the end, okay? So we're just setting up all the base stuff right now for later on when we actually want to start adding things such as, you know, doors opening and closing, notes appearing on screen. So what we're going to do is we are actually going to compile, save, and then quit out of this window right here because we don't really need to be using it anymore. And instead, we're going to go back to our main level and we are going to create a new blueprint, and this is going to be a test interaction, okay? Just an object that we can interact with and then print something on screen. So I'm going to create a new blueprint class right here. I'm going to make it of type, not any of these common ones, but if we go down to all classes, we can search for interactable and select that as our parent class. And then I'm going to call this one test interactable, okay? Because we're not really going to be having this in our final game. Rather, this is just to test the actual functionality of the interactable. We can then open this up. And for this, we're just going to add in a box component right here. A cube actually. So we're going to add in a cube component right here. And then inside of event graph, you'll notice that, you know, nothing has really changed. So instead, what we need to do is we are going to select these sort of nodes that are already here, delete those, and we're going to right click and we're going to search for begin interaction, okay? Add event, begin interaction. So what we are doing here is we are basically not creating an event, but rather we are sort of overriding the event that is being called on the base interactable blueprint, okay? So basically, instead of the one on the interactable blueprint being called, we're sort of snatching that away and going to be reading the value and executing it ourselves. Now, we still want those blueprints where we are setting the variables, the can interact and single interaction. We still want that to run. So in order for that to run, we need to right click on this event and we are going to go down to where it says add call to parent function. And then this is going to pop up here. We want to connect it like so. And then all the logic from here, we then want to output from this parent interact node. And all we're going to do is just go print string, and we're just going to say interact happened. Okay, so now when we ever interact with this cube, it should just say interact happened, and that should print to our screen. So I'm going to compile, I'm going to save, I'm going to go back to our main level and actually drag this out into our scene right here. And if we press play, you'll of course see that, yep, nothing happens because we haven't set up the ability for our player to detect and work with interactions. And that is what we're going to be looking at in the next lesson. So thanks for watching. Welcome back everyone. In this lesson, we are going to set it up so that our player can detect these interactable objects. Now, the first thing we need to do is go to our project settings because we need to add in a new input. But this isn't going to be an axis mapping, rather it's going to be an action mapping. Now, the difference between the two is axis mappings, these events basically output a value, okay, between -1 and 1. Whereas an action mapping just outputs an event when a certain button is pressed. In this case, our interact button. So I'm going to call this action mapping interact, and I'm going to click on this little keyboard icon and press E. So whenever we press E on an interactable, that should interact with it. So we can save that, go over to our player blueprint. Now inside of our player blueprint, I did actually encapsulate these nodes inside of a comment. You can do that by selecting a group of nodes, right-clicking and going create comment from selection. Now, inside of our player blueprint, what we need to do is we first of all need to know what we are currently looking at, okay? And to do that, what we're going to do is we are going to get the event tick node, bring that down here. Now, the event tick node, as you may know already, this gets triggered every single frame. So if we're running our game at 60 frames a second, this event tick node is going to go out 60 times per second. And what we want to do every frame is basically shoot a line from the center of our camera forwards a certain distance, okay? So we might want to shoot it forward like 2 meters or so. And if an interactable hits this line, then we want to basically set that as our current interactable. And if we press the interact button, so if we press E and we have a current interactable, then we want to try and interact with it. So from event tick, I'm going to plug this into a line trace by channel node. Now, this is a pretty big node. It's got a bunch of inputs. The only inputs we really need are the start and the end, okay? So the start is going to be where this line begins, and end is going to, of course, be where it ends. For start, we want this to be our camera's position, and the end is going to basically be a couple meters in front of the camera. So for this, what we're going to do is we are going to get our camera, drag that in like so, get camera, and we're going to drag off from it and go get world location. Now get world location is going to basically be the position of our camera, which we can plug into start right here as the start location. Now for end, this is going to be a bit different, okay? We're going to need a few more nodes for this. So what I'm going to do is from camera, I'm going to go get world rotation. Okay, so this is going to get the rotation of our camera. And from this, we can then get the forward vector. So from the return value, I'm going to go get forward vector. And this is going to basically get the forward direction that our camera is looking in, okay? So after we know what direction our camera is looking in, we want to then multiply that vector by a number such as 250. Now, you may notice that when I put this in a multiply node, it is multiplying it by another vector. Now, we don't want that, so what I'm going to do is I'm going to right-click on that pin and go convert pin to a float, and set this to be 250. Then we can add this to an addition node, an add node, and basically we just want to add our world location to this new vector, and then plug that into end right here. So basically what we're doing here is we are shooting a line from our camera's origin in the direction of our camera by 2.5 meters, okay? So there we go. So now that we have done that, what we can do is go to the right-hand side, the outputs of our line trace by channel node, and this is where we are going to start looking at stuff. So first of all, what we want to do is we want to get the out hit and plug this into a break hit result. Now this break hit result, because this out hit contains a lot of information that we can use. And as you can see, this has all these different outputs that we can retrieve. Okay, so we can know, for example, the time that this hit, the distance away, the location, the normal vector, the material, the actor that it hit. Okay, we can know a lot of information about what we are hitting with this line trace. But the only thing we really need is going to be the hit actor. We only really need to know what thing we hit, okay? If we hit anything at all. So I'm going to drag out from hit actor and plug this into a cast to interactable node. Now, cast interactable, we give it an object and it tries to convert it to a interactable blueprint type. Now, our test interactable blueprint, that has the parent class of interactable, so that would convert over well. Yet, if we're looking at the floor, for example, that isn't of type interactable, so it is going to output the cast failed output right here. Whereas if it is successful, it's going to output from the top one. So we want to carry on the flow from our line trace node into this cast interactable node. And we can actually close this break hit result node up a bit so it's a bit neater. And then what we want to do is if this cast to interactable was successful, so if we did actually hit an interactable object, we want to plug this into a branch node. The reason why is because even though we hit an interactable, we want to make sure that we can actually interact with it, because if we can't interact with it, we basically want to ignore it. So how do we check that? Well, as you can see here, we have the as interactable output, and I'm going to drag that out and go can interact. So we are going to get the can interact value from that blueprint and plug that into the condition like so. Okay. So now if we are able to interact with this blueprint, with this interactable, it's going to be true. Otherwise, it's going to be false. So if we can, then what we're going to do is we actually need to create ourselves a variable, and this variable is going to keep track of whatever interactable we are currently looking at. So I'm going to create a new variable here called current interactable, and this is going to be of type, if we go up here in the details panel, it's going to be of type interactable, okay, which is right here. Now we can click compile, and current interactable, we want to drag that in and go set current interactable. Plug this into the branch's true output, and the value is going to be the as interactable right here on the cast. Okay, so basically we are setting this current interactable variable to be whatever interactable we are hitting, as long as we can actually interact with it. So there we go. Then what we want to do is make sure that if we are no longer looking at an interactable, or if we're not looking at an object that can be interacted with, we want to set that to be nothing. Okay, so I'm going to drag current interactable in again, make a set node here, drag the cast failed into that, and also drag in the branch false output into that as well. Okay, so now what should happen is if we are looking at an interactable that we can interact with, it is going to have it assigned to this variable right here. Otherwise, if we are not looking at an interactable, or if we are looking at an interactable that cannot be interacted with, it's going to set this to basically be nothing, okay? So there we go. Now, that's a lot of nodes right there to look at, but let's continue on real quick with setting up the ability to actually press E on this object and interact with it. So I'm going to create ourselves right here, the interact, this is going to be the event interact input right here. And then when we press it, we want to check to see is valid. Okay, in the is valid node, we give it an object, and if that object has a value, it's going to return is valid. Otherwise, it's going to be is not valid. So what we want to do is the object, of course, is going to be our current interactable. So we can plug that in like so. And if this interactable is valid, so if this current interactable does have an actual value, then we want to go ahead and, from current interactable, call the begin interaction event like so. So that's what we want to do right there. We can now click compile, save, go back to our main level, and if I press play, you'll see I can look around. Now if I press E, nothing's going to happen. If I look at the ground, nothing's going to happen. But if I walk up to this cube and press E on it, you'll see that it says interact happened right there, okay? And if I look away from the cube and stop pressing E, you'll see the messages are no longer appearing. If I press E on the cube and I slowly walk away, you'll see that after a certain distance, it stops because we're too far away. So you can basically imagine that there's a laser pointer in the middle of our eyes shooting forward about 2.5 meters, okay? Now, if I select this interactable, and in the details panel, I go down and enable single interaction and press play, you'll see that I can only interact with it once, okay? I pressed E, it says interact happen, but I can no longer interact with it again. So that is just a way that we can set it up so that we can only interact with an object once or as many times as we wish. Really, we can create anything such as doors, fire pits we can turn on and off, and like I said before, notes that we can then read. Welcome back everyone. In this lesson, we are going to be setting up our Nav Mesh and our AI navigation for our project. Because since we are using units that we aren't directly controlling with an input, so we're not really telling them to move left, right, or whatever, instead we are telling our units to move to a specific location. And if there is an obstacle in the way, such as a box or a big rock, we want our units to move around it rather than trying to go directly through the center. So how do we do that? Well, first of all, let's go ahead and just add in some obstacles. So I'm just going to go up to here where we can add in some objects. And I'm going to add in, let's just say, a cube, okay? You can bring that down like so, maybe increase it in scale a bit. And I am just going to move a cube here, duplicate it with Control D, and just place a couple of them down here, just so we have an understanding of what this Nav Mesh does. Okay, so we have our cubes placed down. Now, let's just say we have a unit that is behind this one right here, and we want it to move on the other side. Now, typically, when you'd move a blueprint or move a character, you just basically tell it to move in the direction that you want it to. Yet, we can't do that because there is an obstacle in the way right here. And we have to create what's known as a Nav Mesh, which is basically an asset that determines all of the walkable space in our level. So how do we do that? Well, let's go up to this little drop down here where we can create objects. And actually instead, we're not going to go here. We are going to open up the Place Actors menu or the Place Actors panel. And if you don't have that, you can just go Window, Place Actors right here. Now in Place Actors, what we want to do is we want to look for Nav. And you should see here that we have ourselves a Nav Mesh bounds volume. And we want to drag that into our project here. Okay. Now, you'll see that this is sort of like a cube, but without the visual. And this is because the Nav Mesh bounds volume basically defines an area of which it will generate a Nav Mesh for. So what we need to do is go to our details panel. I'm going to set the location to be 0 on the X, 0 on the Y, 0 on the Z. So you can see it's pretty much in the center of our world right here. And we need to basically increase the size of this selected box here. So to do that, we can scroll down in the details panel and we want to go down to the brush settings, okay? And you see here we have the X, Y, and Z values. Basically, we just want to, when I increase these, we can basically change how big this is going to be, okay? So just make sure that the bounds of this box here fit our level, because only the objects within this selected boundary are going to be calculated for a Nav Mesh. Now, we've got that here, but how do we know it's working? Well, what you can do is press the P key on your keyboard, and you should see now that we have the walkable ground selected, okay? So you can see here around our cubes, we have this sort of like a gap, like it's been cut out, and that basically means that our cubes are defined as non-walkable. If something wants to walk through a cube, it is going to calculate a path going around it, okay? So basically, whenever we want to move from one spot to another, it is only going to be moving on this sort of selected green plane here. So great. That is how we can set up a Nav Mesh bounds volume. Now, in the next lesson, we are going to be looking at creating a unit which can actually utilize this and move from one spot to another using AI. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to begin creating our units. So first of all, we want to go down to our content drawer, and we want to go to our content folder where we have our level and our other blueprints that have already been created. And what we want to do is right click, go blueprint class, and we want to select the character blueprint, okay? And I am going to call this one unit. Now this is going to be the base blueprint for all of our different units, both the player and the enemy. And then from here, what we're going to do is we're going to extend from that for the player units and extend for that for the enemy units, okay? So if you do want certain logic such as AI for our enemies, because our enemies are going to be able to attack on their own when a player gets within range, but we don't want our players to do that, so we are going to basically have a separate player and a separate enemy blueprint, okay? But this unit blueprint is basically going to be the parent class for both of those. So all of the similar logic, such as being able to move to a location, move to a target, is going to be shared between them inside of this blueprint here. Okay, and we'll get a better understanding of how that works later on once we start setting up the others, but for now, let's just open up this unit blueprint by double clicking on it, and we can then dock it in like so, just to make it a bit neater. Now, the first thing we want to do is give ourselves a 3D model, because right now we have no visual. So what I'm going to do is I'm going to open up the content drawer, I'm going to go to our models folder, and I'm just going to drag in the Bishop 3D model under the unit here. Okay, we can select that model, and what we want to do is we basically want to drag it down so that it is sitting at the bottom of this capsule right here. And this capsule is basically defining the bounds of our unit. Now, let's actually disable the grid snapping here so we can move it up a tiny bit just so it fits correctly. There we go. And let's also give it a material. Now, to give it a material, we can go over to our details panel, go down to the materials, and let's give this one unit, I'll give it unit underscore 1, which is just a blue one like so. And there we go. So that is our 3D model, pretty much all set up. Now what we need to do is go over to the event graph where we are going to be spending most of our time setting up the various different pieces of logic for our unit. Now, inside of this unit blueprint, we are going to be making a bunch of different things. First of all, we're going to have it so that this unit can move to a target. It can also move to a position in the world. For example, when we right-click on the ground, our player is going to move to that position. When we right-click on an enemy, we want it to move and attack that enemy. We're also going to have logic that works for attacking a target when we get within range, and also for taking damage. So let's start simple and just get our unit moving. So first things first, we need to create a variable here which is actually going to determine the position we want to move to. So I'm going to create a new variable down here. I'm going to call this one target position. Over in the details panel, we can change the variable type from a boolean over to a vector, which has an X, Y, and Z coordinate that we are going to move towards. We can click compile to save all those changes. And then over inside of begin play, what we want to do is initially we want to set our target position to be our current location. And that is because we don't want our unit, to start moving over to 000 at the start of the game. We want them to stand still. So we're going to set their target position to basically be their existing one. So from begin play, I'm going to drag out and go set target position. And the target position is basically just going to be get nav agent location. Okay, so that's going to get the location of our AI agent. And an agent is basically an entity that utilizes a Nav Mesh. So it's basically going to get our current location on the Nav Mesh. Now, the active begin overlap node, which detects collisions, we don't really need that, so we can actually go ahead and delete it like so. But the event tick, we definitely will need. Now, with event tick, what we want to do is we basically want to be moving towards our target position at all times, for now though, okay? So what I'm going to do is I'm going to drag out from event tick here with the control, and I'm going to drag this into a node called AI move to, okay? This one right here, AI move to. And this node right here, basically we give it some information and it is going to automatically calculate a path and move us towards our target location. So what information do we need to give it? Well, first of all, we need to give it the pawn or the object that we want to move, which is going to be our self. So we can just right click and look for the self node right here, get a reference to self, and drag that into the pawn. Now we also need a destination. And of course, that destination is going to be our target position. So we can drag in target position, go get target position, and connect that up like so. Okay, and pretty much that is all we need to do. So now if we compile this, if we go back to our game level, we can actually go to our content drawer, go back to content, drag in a unit here. There we go, they're on the ground. And if we press play, you'll see that nothing happens because we initially set their target position to be their existing one. But what happens if we don't do that? What if we go to unit? What if we right click on the begin play node and just go over to where it says break node links? That will disconnect it. If we click compile, if we go back to game level and we move our player over here, for example, and we press play, what you'll see is our character now moves over, or it's trying to move over to the 0, 0 coordinate, which is pretty much inside of this cube right here, okay? So we can move it over down below here, so there is an obstacle in the way, and as you can see, it moves around this obstacle towards the target. Now, you may think it is moving a bit fast, and it kind of is, so what we can do is go over to our unit here, and select our character movement component, and what we want to do here is just change the move speed. So if we go down to where it says max walk speed, we can change that to, let's just say 300. So now if we compile that, go to our game level, press play, you'll see that we move at a much slower speed and we can see the AI navigation a bit easier. But yeah, that is basically how we can navigate around obstacles using the AI move to node. Now I'm going to reconnect the begin play to that set target position because we do want to actually have our target position set to whatever we are right now by default. And in the next lesson, we are going to be looking at making it so that we can actually tell our player where to move. Okay, we're going to be able to select our player with left mouse and right click on the ground to move to a position. Okay, so we're going to get that RTS movement and interaction set up. So thank you for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to get our player controller set up and working so we can actually start selecting our units and moving them around. And we are first of all going to actually create another unit blueprint, okay? And that is going to be our player unit. Because this unit right here, this unit blueprint, we aren't going to ever be using it, okay? So let's go ahead and delete our unit that exists in our world right now because we're never going to drag this unit blueprint into our world. Rather, we are going to create two other blueprints, a player unit and an enemy blueprint, and those are both going to inherit, or they're both going to be a child class of this unit blueprint, okay? So it's basically we want the enemy and the player to both have the same characteristics and the same logic as each other, but they're going to differ in certain ways that we do want to give themselves different behaviors, such as the enemy is going to have automatic AI and the player is going to have the ability to be selected. So I'm going to right click, I'm going to create a new blueprint class, and this is going to be and we need to pick a parent class. Now we want to go all classes because we want to search for our unit right here. And this unit is going to be our parent class. And I'm going to call this one player unit. Now what happens if I open this up, you'll see that we have the player bishop right here. We have everything set up just as it is over in unit. Yet if we go to event graph, you'll see that our begin play connects this thing called parent begin play. And parent begin play is basically what this code here, or this logic over in unit that we are setting up here, okay? Because everything inside of player unit is sort of overriding or inheriting from unit. That stuff already exists, and any changes we make to the unit blueprint, those changes get applied to our player unit as well, okay? And then what we can do is just attach on extra logic, extra gameplay behaviors to our player unit here that are more player-centric. And if we create the enemy blueprint, that's going to be more enemy-centric with the AI, okay? And of course, we'll get into this a bit later on the specifics, but for now, just know that player unit is basically inheriting everything from this unit blueprint right here with the ability to add on its own extra unique properties. So now what we want to do is open up our RTS player controller blueprint right here, and this is going to be where we are detecting all of our mouse clicks and keeping track of which units we have currently selected, okay? So inside of the player controller, what we want to do is go over to our event graph here, and we want to create ourselves a new variable. And this variable is going to be called selected unit, okay? And the variable type is not going to be Boolean or vector, rather it is going to be of type player unit, like so. We can compile that to save those settings, and now what we need to do is we need a way of basically determining when we click on a player unit. So first things first, in begin play, we're going to connect this over into a show mouse cursor node and enable that because we do want our mouse cursor enabled by default. We then want to delete event tick since we won't be needing that, and instead we want to create a left mouse button node. And this left mouse button node is going to basically execute once the left mouse button is pressed or released. Now what we want to do is we want to basically determine if we are clicking on a player unit when we select with the left mouse button. So how do we do that? Well, we need to use a raycast, okay, or a hit result. So for this, what I'm going to do is I'm going to create a node called get hit result under cursor by channel. And this node right here, basically it is going to shoot a laser beam from our mouse cursor to whatever we are pointing, and it is then going to return to us that information whenever it hits something. Now from hit result, we want to bring this over into a break hit result node right here. You can then pop that open to see all of the different outputs we can choose from. Now the thing we want to check to see is the hit actor, and we want to know if whatever actor we hit with our mouse cursor is a player unit. So we can drag that out like so, and we are going to put this into a cast to player unit node. Now a cast to node, it basically takes in an object as an input, and it basically determines if this object is of type player unit. If it is, this control flow executes, otherwise cast failed executes. So basically, this is only going to be true if the object we are clicking on is a player unit. So let's connect this up with the pressed input like so. And then from cast, if it is indeed a player unit, then what we want to do is we want to basically go set selected unit and go as player unit in like so. So now when we left click on a player unit, it is going to set it as our selected unit. Now, how do we get that unit to actually begin moving around once we have it selected? Well, for that, we are going to create another event node called right mouse button. And right mouse button, this gets executed when, of course, we click on our right mouse button. And what we want to do with this is we basically, to start off with, want to see, first of all, do we have a selected unit? And if we do have a selected unit, then we want to move it to whatever location we have hit. So what we can do here is actually just to save some typing, I'm going to select our get hit result under cursor, hold down control and select the other node here. I'm going to copy that and paste it down here, okay, just because we don't have to worry about creating those nodes again. And instead of the hit actor, we want to get the location, okay, but we don't want to get that just yet. Instead, what we want to do is we want to go out from pressed, and we want to check to see if we have a selected unit, because we don't want to try and move somewhere if we don't have a selected unit. So out from pressed, what we want to do is we want to check to see the is valid. Okay, is valid right here with a little question mark icon. Basically, we give it a object and it determines if it exists or not. So right now, our selected unit, if we get it like so and plug it in, if it has not been set, it is equal to what's known as null. Null basically means empty. And if it's empty, that means it is not valid. Otherwise, if we have set the selected unit, it will be valid. Now, if it is valid, then we want to basically set its target position. And to do that, we're going to go over to our player unit right here. And actually not our player unit, we're going to go over to our unit. So our base unit, because this could also be given to an enemy. And we are going to create a new function down here called move_to. Okay, and the move_to function is going to contain a input. So we can add an input right here, and it is going to be called toPosition. We want to make that of type vector. And basically what we want to do is set our target position to be this toPosition. So we just want to plug it in like so, and there we go. So basically, when this move_to function is called, we send over a position, and it is going to set our unit's target position. Now we want to click compile, go back to our RTS player controller, and then what we want to do is we want to drag in our selected unit here, go get selected unit, drag that out, and we want to call the move_to function like so. And we want to connect that to the isValid of the isValid node. And the toPosition is going to be the impact point, okay, the point at which our mouse cursor has impacted probably the ground that we want to move to, okay? So that is what we need to do in order to basically set it up for our unit to be selected initially. And then when we right click, we want to check to see if we have a unit selected. And if we do, we want to move it to wherever our mouse cursor has clicked on the ground. So now we can click compile. We can go back to our game level. We can then drag in a player unit here. And let's actually drag in another one as well to basically see if this selecting works. Click play. Okay, and now what we can do is we can click on our unit. So if I click on the left one right here, nothing really happens so far, but we will have a selection visual appear. And if I right click, you'll see that our unit is now moving to whatever position I am giving it, which is pretty cool. Now, if I select this other unit with left mouse, as you can see, I am now controlling it, and the other one is staying still. So we can switch between our units here and move them around wherever we wish by clicking on them, and then right-clicking on the ground to basically navigate over to that location. So that's all working nicely right there. All right, so we got that all set up and ready to go. Now, in the next lesson, I reckon we look at setting up some sort of enemy, okay, because we need a way to actually begin attacking other units and then later on them having the ability to attack us. So thanks for watching, and I'll see you all then in the next lesson.